Hey everybody, today we will do another video and we will do some circuits. So basically today we will discuss one problem. I think one problem only in this topic is not as popular. It's called linearity property. Well basically what this topic does is it kind of, let's say that you have a system. In that system you have a bunch of components right inside, but in that system you will have, it will sum up to a certain amount of voltage or a certain amount of current. So but you will be able to kind of pull out some constant that the voltage and the current will increase in that according to that constant, either increase or decrease, right? So for example, in the case of it says that if the current increases, right? It has to do also with homogeneity, right? And we study differential equations. We go through a series of homogeneous differential equation, which is kind of odd. What name, right? Homogeneous, weird. But anyway, so basically, what it does is it's like this. So let's say, for example, that you have it said if the current increased by a constant K, right? If the current is increase by a constant K, right? Then the voltage increases by a constant K, right? Then the voltage increases right by a constant K. All right. So, but this are just words, right? Obviously, words for some people work, right? But for engineers, this doesn't mean too much, right? So what we do in engineering, we try to define that in a little simple manner. So it said that K-I-R, right? K-I-R, and you remember this is Ohm's law. This right here is just Ohm's law, right? Is equal to K V, right? In other words, if I divide by K on both sides, what do I get? I get V is equal to IR. Actually, they have a small I and capital R. And the reason why they have capital small I in this case, I guess they already tended to go to the chapter where we deal with time-based current, right? So basically, that's how we actually define that, right? So in other words, if current increases on both sides, then the voltage increases, right? Now let's say, for example, you divide this guy by R, right? Divide by R on both sides, then you get the current. But the current is also proportional to the voltage, directly proportional, and you have a K in front of it. What I'm trying to say is if you have K I R equal to V KV, right? It's equal to KV, right? You want to solve for R, right? You just want to solve for I, right? So divided by R, right? And what you get KI, right? Because you divide those two, it's equal to KV divided by R, which is same Ohm's law, right? So then same thing, you divide it, divide by K, and you get just Ohm's law, right? But this is you can see that they both have a K, and that's what that statement is trying to say, right? Anyway, okay, so basically, and we will do one example. Okay, so the example state that we have a current source, then we have a current. It's called, in this case, they call the I4, right? They have an I4 going in like this. They call it this I4, right? And then they have a resistor right here. That's the first resistor, and that resistor is 6 ohms, right? Next, we have a node, and going down, and we have another resistor, right? And that resistor value is 7 ohms. 7 ohms, right? Now we have in this case right here, we have what is called V2, right? So we have, it's divided by nodes. What they've done is kind of divided by nodes, right? Node 1, node 2, whatever, right? But in this case, we have V2 right there. So V2, this node, right? Then we have another resistor right here, right? We have a current coming out of this node, right? And they call that I think it's that's I2. They got another current going down. They call that I3. And then they have a resistor. They call that 2 ohms. 2 ohms, right? Now, I got another node right here, which they call this node 2, and they call this node 1. And then in this node, I have another resistor going down, and that is 4 ohms, right? So And then they call this I1. And then they call this node right here, because it's in this node 1, of course it's going to be B1, right? Let me just do it right here. So I get, this is 1 belong to this node, and this is B1, right? And then I have a resistor of 3 ohms and 5 ohms. I have 3 ohms and I have 5 ohms, right? And then in this case, right here, I have, yes, I have 5 ohms, right? And just, let me just fix this a little bit, because, right, like that, because I need to put an arrow like this. I get another current going down in this direction, right? And that current is, they call it IA. But this guy right here is 5 ohms, right? Now, this is the circuit, right? So I have a current going in, I got a current going to the resistor, and of course coming out of this node, and then from this node I get one current going down to this resistor, another current going down to that one, and then and so forth, right? Now, let's do this, right? So what can we do here, right? That would be the question. Now, this is a very important about problem statement. They say, assume, right? Assume A is equal to 1 amp, which is that guy right there. Use linearity to find the actual value of A in the circuit below. Use linearity to find the actual value of IA, right, in the circuit below. Right. That right there is the problem statement. Okay. Okay, so they already told me what this is, right? Why are they asking me to find the actual value? Well, this is the thing. And you know what? I forgot to put this right here. This is IS. IS is equal to 15 amps. So the source is 15 amps, right? They want me to find the actual value of IA. I don't know. I mean, I guess that I don't know what that's going on, but okay. So basically, so we have the source, right? 15 amps, and then we have the source of 50 amp, and then we have this system, right? 15 amp going to the source, and assuming that guy is 2 amp, right? That's what we're doing. Okay, so So basically, what can we do, right? Based on our experience in how to do circuits, right? We know that this guy is in series with that, right? So what we can do is we can find B1, which is this node, right? We can find this voltage, right? By saying that B1 is equal to 3 plus 5, right? Times IA, right? Why? Because these guys right here are in series, so I can combine them, right? Times the current that was given to me, right? So that is going to be equal to what? It's going to be equal to A times 1M, right? A ohms, right? Times 1 amps, right? Is equal to what? Is equal to 8 volts. So I found this guy, right? It makes sense because these guys are in parallel, right? These two guys are in parallel. So the voltage across this node should be the same as the voltage across that node. Right? So now, with that being said, I can say, well, can I find the current in this? Yeah, can I find I1? Yeah, because if the voltage of this node right now is 4 volts, 8 volts, then I can say that I1 is equal to B1, which I found, over 4 ohms, right? 4 ohms, right? 4 ohms, right? Which is equal to what? Which in this case is going to be equal to 8 over 8 volts over 4 ohms. It's equal to nothing but 2 amps. Now I found the current across this node, right? Now, look at this. What do I have? I have I2, right? I got I2 now. What can I do with that current, right, to find I2? Well, notice that the voltage across this guy is this, right? So V2 is right here. So V2, I can say that V2 is, okay. So I2 is this, right? So I2, I don't know yet, but I know that this voltage, I know the voltage at that node, right? So what can I do? That will be the question, right? So in order to do that, I can say that I2, right? I can say that I2 is equal to this guy plus that guy, right? So now I can say that I2 is equal to, because I found I1, right? So this is I1. So I2 now is I2 plus I1, which is equal to what? It's equal to 2 amps, 2 amp plus the one that was given, right? Plus the one that was given, that was IA, right? I can actually say IA instead. Yeah. So I1, I'm sorry. I1 plus IA is going to be and I know that I1 is 2, so it's going to be 3 amps. Okay, so now I am here, right? I found this guy. Now notice that I have resistance over here, right? Now what can I do? Now I can say that B2 of this node is going to be equal to B2 V2 at that node is going to be equal to the current going through this node, which I found it, times the resistance, which is going to be 2I2, right? And I2 is, now I2 is 3 amps. Now I2 is 3 amps, so V2 is going to be equal to 2 times 3 amps, right, is equal to 6 volts. Okay. So now I got a V2, I am here now. See that? Right. So now we can say, so what is actually now B, you can call it B source or whatever, right? Technically, that's what we actually dealing with. So I am in this node, right? Let me just correct something right here. I am in this node. What am I looking at? I am looking at the voltage across this system. At the voltage across this current source. So basically, what I can do is plus B1. What was B1? B1 was this guy. So what I can do is B2 is equal to 2 times 3, right? The current, right? I2 is 3, and that resistor is 2, plus V1, which is a volt, right? So when I add those, I get V2 is equal to 6. 6 plus 8 is equal to 14 volts. So now I am here, right? This guy now is 14 volt, this node. Now again, going in Ohm's law, right? Using Ohm's law. So right here, this guy is 14 volt. That point right there is 14 volt. Then I said that the current in this guy, right, is going to be the voltage divided by that resistor is going to be I3 is equal to V2 over 7 ohms, which is equal to 14 over 7, which is equal to 2 amps. Right. So I2 now is equal to 2 amps. I'm sorry, I3 is equal to 2 amps, right? I3 is equal to 2 amps. Now, what is the last one I need to find? I need to find this guy, I4, right? To find I4. And I4 can be considered as I3 plus I2. So I3 plus I2, right? And I3 already found that it's that guy. So I4, which is this guy, is equal to I3 plus I2, right? And what was I2? I2 is 3 amps, right? So now I2 is equal to 2 plus 3 amps is equal to 5 amps. 5 amps, right? Now we have 5 amps, right? I'm sorry, this is I4. I4, right? So now looking at this, right? Notice where this current is coming from. Well, it's coming from this source. but the source is telling me that I have 15 amps. Why don't I get 15 amps over here? That would be the question, right? That would be the question. Why, instead of getting 15 amps over here, why I only get 5? Why? That would be the question. Now you can say that the book has it like this, which I don't agree with, but it is what it is. I mean, I'm not gonna. They call this I5 is 5 amps, and also they call this, IS. IS is equal to 5 amps, and IS is equal to, IS is equal to 5 amps, also I source is equal to 15 amps. I don't know why they didn't name anything different. I would have named it something else, but, okay, so now I know that having this in, so basically we can say that the I source is 15 amps, but also I source 5 amps. Therefore, the multiplier of this to get 15, what number is it? Out of the all numbers that we found. Is it 2? Right? Or is it 3 to get 15? And obviously, it's 3. So the actual value, so the actual value, so, okay, let me just do it right here. The actual value, right? The actual value, right, of the actual value of IA is 3. You can say instead of equal is 3 amps. So that's the answer. Why? But you can see that all the numbers that we found, the one that only makes sense to make that 15 is 3, right? Because I source, obviously, you could have said that it's 3, that is 5 too. But it doesn't make a lot of sense, because how the multiplier can be larger than the source, right? The source normally, constant values are usually there to express linearity, but not necessarily have to be larger than the source. If I say that the source is 5, which is, you can say 3 times 5 or 5 times 3 is equal to 15, right? So the number that is missing over here is, in this example, IS is equal to K times 5, right? Times 5 amps. So what is K then? What is K, right? Well, K is 3 amps. And that's why we found out that the linearity, the actual value of K in this case is 3 amps. So that's it for today, guys. I hope you learned anything in this video. Remember that this is the Conservative Engineering Academy. We actually learn something every day in this channel or in life. It doesn't have to be engineering, right? Because Jesus is good with us. Without Jesus, we are nothing, right? And I have to put this out over there, because a lot of people don't understand that that without God we cannot do anything. And that's it. I mean, I have to be clear. I mean, this channel we talk about Jesus. We praise the Lord in this house. So I am not, I will not be ashamed to express that I love Jesus. Just expressing myself that I love Jesus first than this. Right? Let me make that crystal clear. I love Jesus before this and before everything else. Right? So, thank you for watching. See you in the next video.